Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
My guest today is Norman Mier. He is a U.S. Marine Corps retired veteran with over 20 years of experience in the electronics rework and repair industry. He received his training through the Navy's Micro Miniature 2M electronic repair program. He has progressed through every level of rework and repair recognized by the industry. Norman has also earned the highest certifications awarded by IPC in the electronics training, being certified as a Master Instructor in IPC A-610, J-STD-001D, IPC WHMA-A-620, and IPC 7711 and 7721. He has worked through Best Incorporated for several electronics industry leaders and created tailored courses for their equipment. This also includes providing training to technicians and engineers in surface mount and advanced surface mount technology. The knowledge Norm has brought to these companies has been invaluable to their process improvement efforts. His skill has also been a major factor in keeping Best Incorporated training at the forefront of the electronics training field. I'm thrilled to welcome my guest today on the subject of rework and repair, Norman Mier. Norman Mier, thanks for joining me on Reliability Matters. I really appreciate you being here today.
Well, thank you, Mike, for having me here into your show and talking about rework and repair today.
And just before we went on the air, you had mentioned something about rework, and I love when I bring subject matter experts on because I know this much and you guys know this much, right? And you kind of corrected me, which is great. Anytime something needs to be worked on, I just consider it rework. But you were very quick to point out the difference between rework and repair. So tell me what the differences are. What's the definition of those two?
Okay, in accordance with the industry standards and everything in the definition, rework is actually where you would put it back into its original engineering drawings and designs. Like you take off a resistor or a transistor and you put the exact same style back in its place. Whereas repair is where we just get it to function. It doesn't have to meet like the 610 or the J standard. It's just something that's agreement between you and your customer. Like example, a splice. It's a repair, just getting it to function again, attaching it back together instead of replacing the whole thing, which would be considered rework then.
Are there IPC standards on repair, or do they just apply to rework? Or when it comes to repair, is it all bets are off? It's just whatever it takes to get it going?
And there is a IPC 7711 is the guidelines for how to take parts off, how to put them back on, and to clean up the area. Repair is part of that guideline, but it's the 7721 section of it, which is step by step on how to do your job. But there is no set standard on how repair specifications are. It's usually an agreement between you and your customer of how you're going to repair it and what it will look like when it's completed. But whereas the rework, you would probably more than likely follow the 610 guidelines.
Yeah, that makes sense. I guess it would be very difficult to hold IPC standards up for repair, when you're just trying to get it functioning again, right?
Right, exactly.
It's already served its purpose. Now it's going in for its second life, right? It died. Now it's going in for its second life.
Some of them, yeah, it's like a connector. If you break a wire, it's a lot easier, especially in an aircraft, just to splice the wires back together and keep it ongoing from there. Whereas like if a component goes bad on a circuit board, no matter how old it is, that would still be considered rework because the same style of part, everything, you would put it right back into its place.
Yeah, that makes sense. Now, you talked about some IPC standards. I should point out to my audience, you are an IPC Master Instructor. There are levels of instructors, and is Master
Yes.
That's the highest level? That's the highest level of ascension in the IPC world, right?
Yeah. You have it. Your Master IPC trainer, that's what I am. I've been a Master Instructor since 2001. And I train and certify people to become instructors, but also the assemblers. The CITs are the next level down. They can only train and certify CISs. CISs is your assemblers in your facility. So that's your 3 levels that IPC has.
Yeah, that makes sense. And how long did it take you to get up to that level of Master Instructor?
I've been soldering for a little over 34 years now. April 19th, 1987 is when I went to my training. While I was in the Marine Corps, I went to Cecilville, Florida for the course, which was 32 days long. So I've been soldering 13 years on my Marine Corps career. And then when I retired, IPC basically blessed me, and I had to fill out some forms. And I went through my CIT training for 610, which deals with inspection of electronic assemblies. Then I also went to J-Standard, which deals with process control and some types of inspections. And then 771121, which was rework and repair. And then in 2003, I went through wires, cables, and harnesses, which is the 620. So I've been a master instructor. It's just paperwork. And since I've been doing it for a long time, now we used to have to recertify every 2 years. Now it's changed to ongoing training for the master instructors.
Yeah, I would think
CITs, it's every 2 years.
Yeah, I would think in this business that we're in, certifications, maybe hourly could be required. Things change at such a rapid pace.
Yes.
Yet problems from 20 years ago still exist, right? So this is true. Yeah, they don't go away. So we're just adding every so often. We are adding to the complexity and the intricacies of the assembly world, because we're still soldering through-hole components in the days of bottom-terminated components, right? They're all a mix of things on a board today. You work for BEST, or work with or for BEST. Tell me a little bit about what BEST does, and relative to rework and repair and training. And maybe I've just said it all, but elaborate a little bit on that.
Yeah, you did.
Okay, there you go. Next.
The company actually started out as a training company in a 30-foot Winnebago. That's how it all got started, with a gentleman named Bill Westmoreland. And then about 4 or 5 years after I got with them, Bob Wetterman took it over. We were still a training company, but we'd actually been in several years for rework and repair. We have a facility in Rolling Meadows that there's several people in the back. That's all they do all day long is we consider, I say, a crisis management company, where a company has an issue that comes up. We can rework, repair it, or develop a process for that rework and repair so you can do it in-house. But we also, like I said, we've been started out as a training company and just evolved from there. But we also, our third leg is product. We sell easy reballs, stencil quicks, stencil mates, stuff like that for reballing BGAs. That's the easy reball stuff. So it makes it a little bit easier, faster process. We've had that many years now. It's a great little product. And then we got our stencil quicks and stencil mates. So you don't have to use metal stencils, which we can actually fabricate on site. With our company, we have about 6 lasers to do all of this with. So we have a good time with all of that. It's pretty quick and simple, easy product. The first time I had to do easy reball, it's like they said, here, this is how it works. And then I turn around and it's like, that's too simple. And they go, yeah. So I've had fun at trade shows with that.
Yeah, I'll bet. So you talk about crisis management, which piqued my interest. When it comes to repair, I would imagine that's truly a crisis issue, because something's not working. They need it working. And so tell me what a typical crisis management situation is. Is there a typical repair or scenario that brings a user to you, or does it change, hourly, or by the minute, by the second?
It varies. Most of our repairs are where a customer has damaged a board, lifted a pad or a conductor, or burnt the board, and they need that fixed. And we have a couple people at our facility that have become matter experts over the years. of doing that kind of job. And they do a really good job. I've been impressed with the ones that do all of that. And then we have some companies maybe got a capacitor or a resistor wrong, or even an integrated circuit. And they will send them to us, and it might be maybe 100 boards, maybe 1,000 boards or more. And it's cheaper to send them to us with the Matter experts that we have in the back that can take these parts and put them back on. Whereas your personnel are looking for some issues, but they don't have a lot of experience. Somebody at your facility has probably shown them how to do the job. So
yeah, that makes sense.
We do a lot of BGA. We do a lot of BGA rework too.
Yeah, I would think so. What about regular other bottom terminated component, QFNs, things like that? Those are problematic in so many ways, right? Our industry tends to come up with the latest and greatest component without the latest and greatest technique to solder that component or clean that component in my world. So that kind of gets worked out by folks like yourself, right? You kind of figure out how to do it. The component designers design the component based on its function and package size and all sorts of things, but not necessarily, it's not necessarily designed for manufacturability. So when a new component comes on the scene, do you see that like the effects of a tsunami? So many hours later, so many months later, so many years later, it starts landing on your doorstep, or is it pretty instant?
No, after a little bit of time, we'll start seeing like the BTCs, bottom terminated connected components, like the QFNs. Okay, and had to come up with ways to rework and repair them. In other words, you got to put solder paste down there. So what we come up with was a process they did in the back. A gentleman named Hung. He is our rework and repair operations manager. Him and the owner come up with a design for a stencil mate, where we actually use one stencil to bump the part, and then we use another stencil to bump the board. So we run the part through a rework, the hot air system. And then when it's done, then we bring it over. We use the other stencil to do our board, put the part down in, and then run it through a reflow process. And we get more reliability that way. And you're not worrying about shorts or positioning or anything like that, because everything is spot on.
I've heard many consultants, I've interviewed several consultants on the show, and there is a common theme on advice, and that is never repair or rework, whatever the proper term should be in this context, for a cosmetic issue. You're talking about rework. Yes, just leave it be, because the chances are, if you go to rework it to fix a cosmetic thing, you're going to create the possibility for other things to go wrong. Is that a shared belief? When you're in the business definitely. Of rework, you're not in the business of telling people no. So at what point do you recommend? Let me rephrase that. What do you recommend not reworking?
If it meets the acceptability of the customer's requirements and also in accordance with the 610, then leave it alone. That's why one of the issues that was coming up for many, many years as people were reworking to get it, there's used to be 4 conditions in the industry. Targeted condition means it was picture perfect. It used to be called preferred. Then you had your acceptable, which means you had your tolerances. And then you had your process indicator. Something's not right, but it still meets form, fit, and function. Then you had your defect. Well, people were reworking acceptables to put them in the targeted condition. And what this does is you lose a little bit of reliability. Each time you go back in there and rework something or heat it back up, you're increasing the intermetallic layer, that solder fillet between your TID and your platings. So the thicker the plating becomes, or the intermetallic layer, the weaker the solder joint becomes. And now it looks nice. Well, it looked nice before. It just didn't meet the higher standard you wanted it to. So the industry, with this latest revision, we took out the targeted conditions. So now you just had to meet acceptable. So now you have a tolerance to work with. And just leave it at that. Once it meets that acceptability, leave it alone. And when I do I go all over the United States doing solder training in our mobile training center. And I see that all the time. And I get on to students, why are you touching that up? Why are you rework? Well, I don't like the way it looks, or my quality control does not like this. And it's like, whoa, whoa, whoa. The standard is there to put everybody on the same sheet of music. So that's what a lot of these companies need to realize is what I tell students, how you feel, how you think, don't do it.
Right.
You know, what is the standard is, leave it alone. You got reliability right there to start with.
I've said this many times, and my team will probably roll their eyes if they hear this. Fortunately, I don't think they watch the show, so I think I'm safe. But you're never a prophet in your own home. I think that's a worthwhile saying. I used to tell my salespeople, when the customer says yes, stop selling, shut up. All you can do is make it bad, right? So as soon as the customer says yes, stop selling. And I think what I'm hearing from you is, as soon as the part meets an acceptability level, stop reworking it. Stop trying to make it even better, right? It just meet the standard, as you said, be on the same choir sheet, all play from the same, sing from the same hymnal, and then stop. Because the more time that soldering iron is on a part, whatever you're doing, the greater the chance of causing damage or actually reducing reliability. So you endeared me a little bit. I was watching a video on your website where you were showing your audience how to properly solder an axial leaded component. And it was, this is geek stuff now, because how many people will, will watch soldering videos at night? Yeah, but it was a beautiful solder job, and you made it look very easy. But then that impressed me. But what impressed me even more, now maybe this was for some reason that I shouldn't be impressed with, but I was impressed anyway. You were using a no clean flux, and after you soldered this axial leaded component in, you cleaned the residue, and it was no clean. I love that. So tell me, what was that? Just because you wanted to show, what a typical cleaning process would be, or are you a believer in removing excess residue, particularly with no clean?
It goes all the way back to my military days, and when you were done soldering, we used a rosin flux back then, and when you were done, you had to clean it because of that rosin flux residue. But as time progressed, is like the way my belief is, even though you're using no clean, which could be an alcohol or an aqueous based, there's still some type of residue left behind that contamination can get in there, like dirt, lint, stuff of that nature that attaches to it. And then as time progresses, create a deander growth, and then you've got a short coming on. And then also remember, sometimes it flows over onto a connection, and you might not be able to get a good connection.
Yeah. And I noticed another good reason was because the flux was applied, I think with a needle or a squeeze thing, that it wetted out quite a bit. And yet the soldering iron only touched the metallic area, the barrel and the pin. So a lot of that flux was left unactivated. And when I saw that, when I saw you do that, I'm like, oh, what does this guy know? Look, he's making a classic mistake. And then you cleaned it. I'm like, oh no, he's got it. He's got it down. So you passed my residue test. Just so
thank you very much.
Yeah, no certification comes with that, but but you passed that. What are the most common mistakes people make when they try and either repair or rework something? I'm sure there's a common denominator, and it probably changes as time goes by. But what at the moment are the common mistakes people make, and
how do they avoid using
it?
The wrong size tip? That's the number one thing that I do see is, and it's a common theme, and most companies that go do training at is they only have a couple of tips, and their excuse is this is the only ones they give us. But in our training classes, we have a good variety of tips to show that a tip is a tool, and you have a variety of tools, like when you work on a car, you do woodworking or anything else like that, to build a better quality product. And that's what you're trying to do in the end when you rework or repair, is to get that quality product back up and running again. And my thought process has always been is that your rework repair should equal or be better than the original process, and it should last longer than what it did the first time. So that's why I believe in it. I've had a lot of fun doing. My expertise is in rework and repair. I did it for 13 years of my Marine Corps career, and then just took it on over from there. And I like doing that more than anything. And actually, I'm more into repair. I like to figure out going multi-layer repair, getting in there and having to excavate down several layers, almost like terracing, and then fixing that conductor, and then bringing it back out slowly. And then that, when you're all said and done, the product works. And people are like, I'm glad, because we can't get a new board. This is it.
Right. Yeah, I would imagine in the, particularly the repair side of it, there's two skill sets involved. One is the tactical, how to extract a bad component, replace it with a new component, repair traces, things like that. But another is a little bit more strategic. There's a little bit of detective work that has to go on to figure out what needs to be repaired. It's not always the smoldered part, right? That may be the symptom, but there might be 12 other problems that led up to that smoldered part. And just replacing that smoldered part is going to create a new smoldered part. So what tools, what tricks do you have up your sleeve with all that 30 plus years of experience that allows you to see a symptom and then determine what a root cause is?
Well, first off, like you said, you got to find the damaged area, and you see that burn and everything, and you got to look at that. Now you got to know, is this a multi-layer board, single layer board, double layer board, whatever type? And if it's multi-layer, the advantage that we have now is x-rays. So then you can actually put it in the machine and analyze it and see where your break or damage is in the multi-layer area. I like that. It's made it a lot easier on me than having to do the old school of doing a resistor check, using a diode system on a multimeter and just going point to point until you locate it. And then you've got to look at the drawings, and you got to have the drawings to the layers of the board to figure out what layer that damage is done. And then I consider doing a lot of this stuff as like playing chess. You got to analyze the situation, the opponent, which is your board, and to figure out how to beat that opponent in the end.
I think it's like that Star Trek chess, with the three-dimensional chess.
Oh yeah,
even more than just chess, because there's so much to it. How with multi-layer boards with 10, 15, 20, 25, whatever the number is. I mean, they can get pretty gnarly in terms of the layers. Yeah. What tools, you mentioned x-ray, is that the primary tool that one would use to
it is now
see below the surface?
Mm-hmm.
As well as
that way we don't have to get with the customer and ask them for the drawings, because some of the customers will not offer up the drawings because it's proprietary knowledge only for their customer. So when we get it, we have to look at it in a different perspective now. So
they're kind of asking you to find where the treasure is buried, but they're not giving you the map.
Exactly. Right? Yeah.
Well, that's a challenge.
So that's why I really do like using the x-rays now. And then you figure out your layers down through there, and you just do a diode test real quick and get the little beep and say, okay, it's not making its beep, and then start excavating down slowly. And some of the equipment, like the PACE, has a system out there for using, instead of using a Dremel tool or system, it is a Dremel tool, but it has a automatic stop. So you put it on one side of the conductor, and then as you're drilling down into the board, it actually would stop it like on a dime, so you don't damage that conductor. And then you can go in there, excavate around a little bit, cut it, and keep going down, so you know where every layer is at a little bit easier that way too.
This is probably a hard question to answer because there's so many variables, but is there a common cause for failures on a board? Meaning, is it usually latent defects in a component? Is it the design of the board and the circuitry? just leads toward failure? Is it the unexpected in-use climactic environment? Maybe the part wasn't designed for that. Is it all of the above, none of the above?
I'm going to go with all of the above.
Sure.
No, there is no common theme for any of it. In my days, when I used to do a lot of that in the Marine Corps, is like, it might be an electric strike on a bird, a power surge from the generator, just a component failure due to static electricity. So there's so many things that could cause it. So you really can't pinpoint, really, that's what it is.
Right. Do you ever run into a situation where you have to tell the customer, this is just going to keep happening if you don't change X, Y, or Z? Can you see that do you ever look at a board and go, yeah, this is going to fail. I'm going to see this again in 6 months or whatever?
That's a tough one. As a rework and repair technician, in my days, it was different vendors, different parts. So the original design was done with this vendor of parts, manufacturer, supplier. Then for the military aspect of it, they got a new contract. And so now these parts are barely meeting specifications. So when you have a little bit of a surge, which the old ones had a little bit more of a tolerance, then you have that issue. I have seen that in my early days.
Mm-hmm.
So
yeah. Do you ever, I would imagine in your world, particularly when you're doing rework or even repair on military products, the new components that you're buying are probably lead free. I'm guessing you have to re-tin them in a 6337 alloy or 60 foot, whatever you're using. Is that an ongoing issue of having to convert it back, or does the entire board get reworked and resoldered with lead free, or what?
No.
Which way does it go? It goes backwards, right?
If the part is, if we're having to take it, what we call different flavors of like ice cream, you have different flavors of ice cream, and same way on your parts. So if you're having to go from lead free back into the lead community, one of the things that you have to do is what we refer to as rinsing the part. So you're going to clean it off first with a lead solder. So you're going to put that on there first, then you're going to wick it all off. Then you're going to, I'm talking about like a BGA or QFN is where we're seeing this more than anything. Most parts now you can recommend from the vendor what you want, but BGAs, you can only get them in one flavor. So we're having to reball that. So we have to rinse the pad sites 3 times to put it back into a lead fillet. Okay. And then we've actually got on our website on solder.net, we do have a white paper that was introduced probably about 15 years ago or so on that, of how to, like, even using tips, like instead at the same station. And this contract says I'm going to be doing lead, then this contract says lead free. So I learned how to rinse my tips, and that's tinning them 3 times. And then it goes back into a lead tip from lead free to lead. Wow.
3 times.
Yes.
That's surprising. I would have thought just once was enough, but 3 times.
Oh no. Our white paper actually shows it slowly coming down to be within the respectable range.
And I'll have a link to that white paper on our show notes. So for the audience that's listening or watching, I'll send you a link to that white paper. You can download it off of the solder.net website. I'm going to ask you to work yourself out of a job momentarily. Let's say 100% of your job is soldering. And
yep.
What are the most, you mentioned chisel size or iron tip size.
Right.
Besides that, what are the most common mistakes made when someone is hand soldering something, or even for that matter, reflow soldering or wave soldering?
Right.
What are the most common soldering mistakes? And I know in hand soldering, my early days of hand soldering, it was more like solder sculpting, right? I just created a pile of solder and the weight alone would hold the part down. I don't think there was an interconnect there other than the weight pushing the part on the pad. There certainly was no metallic interconnect, but those were the early days of my soldering career, and I'm glad to say I don't have to solder anymore because I was never very good at it. But what constitutes a good solder joint? What constitutes maybe an ugly but still acceptable solder joint, and where does it just go off the rails, and what are the common mistakes made?
Well, the common mistake that I see is what I referred to for some students is they don't know how to reduce the amount of solder that they're going to use. So like everything else, your solder is a tool also. So you got different diameters. You got a 032, 025, 020, 015, 010 are some of the common sizes that we use in soldering. And again, it's a tool, and it should be concave and inward formed. But the other thing that I see is when they're soldering is if they're used to through hole, now they're going to surface mount, whereas you push the solder in through hole. In surface mount, you just lay it there and do like a cutting sensation or motion. That's what a lot of our videos show. And then the other thing is Cro-Magnon knuckle drag soldering techniques is what I call it. Heavy hands cause damage. And it should be the lighter the touch, the better you are. You got to make sure that your pad side is heated up, your solder is above solder melt temperature, and your lead. So if these three things are above solder melt temperature, then you have a good solder fillet being created. And the other thing is get in, get out, don't hang out. Quick little jabs in and out. Like the smaller the parts are getting nowadays, less than 1 second you should be in there. Where the old school thumb for through hole was 1001, 1002, 1003. That's what I learned when I was in the Marine Corps in my solder classes. Count to 3. And
of course, back then, there was quite a bit of mass associated with those leads in the pads, right?
Yes, a lot of ground planes, very thick areas, and that's what you had to overcome too is, and even still yet in surface mount, you have to be careful of your large ground planes. So there's where you're looking at, are you using bottom heaters to get the board up to a warm feeling? And that way, when you go in there with the iron, you don't have a longer dwell time. It's again, get in, get out, don't hang out. So use a variety of tools to your advantage.
I love those. I love those sayings. One of my last questions, at least one of my last planned questions, is conformal coating removal. So many boards, particularly today, with IoT and boards going out into harsh environments, electrification of cars is one example. More and more boards are being conformally coated for a variety of reasons. And when something goes wrong and needs repair, that conformal coating needs to be removed so one can get to the component and then perhaps reapplied. Are there best practice techniques for the removal of conformal coating?
First off, it depends on the conformal coating.
Right.
Yeah. Number one, like there is quite a variety out there nowadays that have a chemical that you can use to dissolve it and get all that out of there. If not, you have to go to the old school, use a little hot air, a little bit of an orange wood stick, and slowly abrade away. But remember, keep your hot air low enough so it doesn't burn the board or reflow the solder fillet that you don't want to do yet. And slowly work at it. Like epoxies, you're going to be using heat and abrasion a little bit to get that off there. Over cure it is some of the techniques, and then cut around it, desolder it, and it should pop right out of there. That was from my military days, that technique was, and it worked great.
Yeah, the military did a lot of conformal coating for obvious reasons because of the climactic in use environment, right?
Yes.
So when one does remove either through microabrasion or chemical or whatever other forced removal of that area, can that be conformally coated back over? Will the conformal coat adhere to the existing conformal coat and create a good adhesive bond, I think of conformal coating and the surface that it is adhering to, which is the laminate of the board and components, being very clean for good adhesion. Can conformal coating stick to conformal coating? Because it does have to, I imagine, overlap a little bit to get a good seal.
It's so far every conformal coating I've ever dealt with is number one thing that you said there was cleaning. Make sure the area is nice and clean so it can adhere back to the board, to the part, and yeah, it will fuse back into the original conformal coating. You'll see a little bit of an overlap with a lot of them. And so I've never had any conformal coating. Only one is the hardest one to actually rework is paralleling to put it back on. And in accordance with some of my friends that they're the matter experts on this, the government has authorized polyurethanes to be the conformal coating to go back on for paralleling because of the process to rework or to put it back onto the board itself.
Right, because paralleling is a vacuum deposition process, and I don't think you can spot paralleling things. It's kind of an all or nothing. Unless you physically mask it, it is an all or nothing kind of proposition. It's not exactly spray it on into an area. Yeah, right. that makes a lot of sense. Finally, and I said that before in my last question, but this is probably the final question. Have you has the source of some of the repair, in your experience, been counterfeit components? Have you ever pulled off a component and had to tell the customer that, you bought this from the wrong vendor, that it's counterfeit, or are they so good that you can't tell, other than the failure factor?
I've never dealt with a counterfeit part. All the years that I've been doing this, I've never seen a counterfeit part. Now, I know our facility has dealt with customers, and that's why we've had to do some rework and repair, is because they obtain counterfeit parts.
Right.
And so that's how we can get some of our business. But I have never dealt with it per se, because like I said, for the last 21 years, I've been the trainer, traveling all over the United States. Like next week, I'm up in Madison, Wisconsin teaching. So constantly on the road.
Do you ever, when someone sends a board to Best and you have to, again, repair it, whose job is it to procure the component? Does the customer want you to do it, or do they send you a tote full of old components that they've had on the shelf for 30 years and say you figure it out, or what?
We've usually comes from the customer. It starts out where we do a quote first, and then Hung in the back looks at it and says how much it's going to cost and everything. And then the customer provides all the parts that we do, any rework or repair that we have to do to anything. Rarely ever do we order it, and then they will give us the information. Then that's how we would order it from their supplier. Excellent.
Are we missing anything? Have we covered the rework and repair? I know we covered probably 1/100th of it, or maybe even 1/1000th of it, because there's so many aspects to it. But have we covered the major bullet points?
Yeah, to me we have, because we talked about tip selection, we talked about fluxes, and that's where some customers, it's what is one of my sayings that one of my friends like is, flux is your friend, but don't abuse your friend. Because a little dab of flux is great, but a large amount, you're going to have more area to clean and more possibility of causing other issues, especially like inside of a connector. And right. That's harder to get cleaned out of inside of there. So you want to minimize it. Okay. And then there's sometimes you can get away with, instead of using any external fluxes, which I'm a big fan of, is that you just use a small diameter with a P3 style flux, which means it has more flux in the center core than a P2. And that way you don't have to use any, I'm not saying you don't have to, but you can minimize using any external flux. Like a prime example would be like a ZIF connector. You try to stay away from using any external fluxes on them because it gets right up into that connector really quick.
Right. So, right, and then that starts the oxidation process
yes.
of the metal, and then at some point, someone tugs on something, the connector breaks off, and and then they have to call you. And
exactly.
Right.
And we're more than willing to come and show you how to do the training yourself, so you can do it in the future, or send it to us, because a lot of times you might not have the manpower to do that rework and repair for a lot of boards. So they start looking around for companies like Best Incorporated that you send us a board, we give you a quote, and then you look at it and say yes or no. And that way we have the quality of personnel to do the job for you instead of you having to train somebody or take them away from what they should be doing to do this rework or repair.
Well, that sounds like a wise bit of advice. Norman Mier, Best Incorporated, IPC Master Trainer, and 20-year, more than 30 years of experience in this industry. Marine Corps veteran. Thank you for your service. Thank you for taking what you've learned in the military and applying it to the rest of the world. I think the world is better off for that. And if you can't do it right, you know who to call.
Exactly.
Ask for Norman.
Call Best.
Do it right, and if you can't do it right, call Norman. Call Best. Well, thank you so much for being my guest today, Norman. I really appreciate it. You're a wealth of knowledge, and I've been wanting to talk rework for a long time. I've just never really known what intersection to enter the rework freeway in, because it's such a vast discussion. So thanks for allowing us to dabble in the rework and repair. Thanks for clarifying there is a difference between rework and repair. I've learned something, which is one of the great things for hosting the show. I get to learn all sorts of interesting things like that. So thanks for being my guest, and I will put your contact information, audience, if you'd like to get a hold of Norman Mier at Best or anyone else there. Just look up the show notes and I'll have contact information there. Norman, thanks again. Good talking to you.
Thank you, Mike, for having me. You have a good day now.
You too. Well, that's another episode. Thanks for listening or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on Apple Podcasts, Google Podcasts, Spotify, or virtually wherever you get your podcasts, or watch the video version on our Reliability Matters YouTube channel. A special thanks to Circuit Assembly Magazine and Ascendo Reliability for syndicating the show, where you can listen to this and other interesting podcasts on PCBchat.com and reliability.fm. And be sure and check out our newest podcast, the Concept to Creation podcast. On this podcast, we have discussions with entrepreneurs of the electronic assembly industry about their journey into business. We discuss their successes and failures, as well as what drives them. You can find that podcast, the Concept to Creation podcast, in the usual places, as well as on our Concept to Creation YouTube channel. Thanks for your questions and episode suggestions. Please keep them coming. You can send them to my email address right down here. That's mike@mikeconrad.com, Conrad with a K. Once again, thanks for listening. Be safe, be healthy, be happy, and keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.